Okay, I'm going to try to attempt to explain some of the basics to blood bank mathematics. So this is coming off Unit 2, Section 5, and deals a lot with the math that's involved in determining percent compatibility and also in helping to figure out or find out how many units we would need to screen in order to find a certain number that are compatible. So all of this has its basis in antibodies that are made by my patient and antigens that I might find on the surface of the red cells that I want to transfuse. So we've got to look at what red cells would be compatible with the antibodies that that patient or that recipient is making. So the very first question says, what percentage of a white donor population, again we're talking about where these red cells come from, will be compatible with a patient who has a strong reacting anti-JKA antibody? So we're going to spend a minute talking about how we read these antigen frequency charts. So this question talks specifically about a JKA antibody. So JKA antibodies come from our KID blood group system here. And I'm afraid that's all my camera is going to zoom in here. So hopefully you have this form already. You can find it online. It says blood group KID, and then it has white donor population, black, and Asian. Just based on different nationalities, we find different antigen phenotypes. So in this situation, it said we've got a person with a strong anti-JKA, meaning that their antibodies are designed to attack the JKA antigen. Oops. So what we need to find then is the person who is going to be JKA negative. So this first row of people here, these are people who are JKA positive, B negative. So they're not going to work for us. The next group is JKA positive, JKB positive, who also aren't going to work. And so finally we get to these last two boxes, JKA negative, B positive, which is okay because we don't care about the B. We're just trying to find JKA negative. And then this last box where they're JKA negative and negative for JKB. That says rare in that there's not enough people in the population to really count or to put there as a percentage. So really what I end up with is this 23% of my population who would be compatible. So the patient laying there in the hospital bed has this antibody. I need to make sure that the red blood cells I transfuse him with do not have the corresponding antigen. So the only set or the only percentage of my white population here who are negative for that JKA is this 23%. So the answer to that guy is simply 23%. Okay, let's look at number 2. And I gotta zoom out here a little bit so you can see what I'm seeing here. So this is number 2 on your homework. It says, suppose you have a patient that has antibodies to both Duffy A and Duffy B. What donor population would be best and why? So we're talking Duffy now. So I can go to this blood group called Duffy. And we can take a look here. And I know these numbers are small, but hopefully you're following along. So Duffy A and Duffy B negative is what we're looking for. So this first group is A positive, B negative. Second row there is A positive, B positive. Third is A negative and B positive. And then finally we have our A neg, B neg group. So if I'm looking to find what donor population is going to be the best for that, only a rare portion of the white donor population is going to have this phenotype, where they're negative for A and B. We find that most of those whites are going to be A positive and B positive. But if you look, we have an interesting thing here where almost 70% of our black population is going to have this phenotype A neg and B neg for Duffy. So they would be by far the best population to pick on for blood units for someone who has an anti-Duffy A and Duffy B. So the answer to 2 is black, because they have such a high percentage of people who are negative for both A and B. And there's some interesting genetic studies about why that is, which I will leave for a different time. So just real quick to summarize these other ones, if you look at the ABO group, you've got O, and this 45% says that's 45% of the population have O-type blood. Likewise, 40% have type A, 11% have type B, and only 4% of our population is going to be AB, assuming we have a white donor population. And you'll see I write a lot of these questions for Utah, which is very obviously predominantly white, which is mostly unfortunate. So anyway, I'm not picking on any race there. It's just how it comes down to what we're looking at in the blood bank. So likewise with this, the Rh blood group, which includes the D antigen, which you'll hear about as someone being A pos or O pos. When we talk Rh positivity, we're referring to that D guy. So with this, we see that 85% of the people are going to have the D, which means the other 15% do not. So if I asked what portion of the population is compatible with someone who makes an anti-D antibody, the answer wouldn't be 85. That 85 are the people who do have it. So the portion of the population that would be compatible would be those 15% who do not make or who do not have D antigens on their surface. So another example, let's say that somebody has an anti-big C antibody. If we wanted to find the portion of the population that would be compatible, I go up and I look at my big C and I say, wow, 70% of the population of donors has that. So the 30% who do not have the big C antigen on the surface of their cells, it's those people who do not have that that are going to be compatible. So the other 30%. Same thing follows suit. If I had someone who had an anti-little e, I would look and say, yikes, that person's in trouble because 98% of my population does have the E antigen. So it would be the other 2% who do not have that E antigen who would be considered compatible with someone who's making the antibody. So I want you to think every single time in terms of the antibody that my patient makes having to match up with the antigens on the surface of my donor cells. If I'm making an antibody to big M, I better make sure that I don't get that 78% of people who have the big M. But if I'm to receive blood, I want to be given blood from that other 22% who are big M negative. So I hope that helps, maybe clarify some things. I will show you in the blood bank part 2 how we can actually deal with the number of units that we need to screen, as well as when we complicate this and add multiple antibodies.